Given the head of a singly linked list, we need to write a function to find the middle node of the list. If the list contains odd number of nodes, then there will be one middle node. And if the list contains even number of nodes, then there will be two possible middle nodes. Your program should support both options, return the first middle node or return the second middle node. Let's understand with example. Here the first list contains odd number of nodes and the second list contains even number of nodes. If the list has odd number of nodes, then there is only one middle node, and in this case the middle node is 30. What if the list has even number of nodes? There are two possible middle nodes. In this case, this node 30 is the first middle node and the node 40 is the second middle node. Let's handle these both cases one by one. Let's develop a function to find second middle of the linked list if the list has even number of nodes, which is this node, and if the list has odd number of nodes, then we will find this middle node. To find the middle node of the list, we'll use very elegant technique called slow and fast pointer approach. The slow pointer will move one step and the fast pointer will move two steps. Let's understand. To begin with, both pointers will point to the beginning of the list. Let's find the middle node of the odd size list. We will use two pointers. First, slow pointer and fast pointer. And initially both pointer will point to the head node of the list. What if list is null? We need to handle that condition. So let's write the condition. If head is null, then we don't have a middle node, so we'll simply return null. Return null. Let's declare these two pointers. Struct node star slow. Initially it is pointing to head. Let's declare fast pointer. Struct node star fast. Again this is pointing to head to begin with. To find the middle node of the list, we'll increment slow pointer by one step and fast pointer by two steps until we reach the end of the list. Let's understand. Let's increment slow by 1, slow will point here, and let's increment fast by 2, so fast will point here. Again let's increment slow by 1, slow will point here, and let's increment fast by 2, so fast will point here. If you notice carefully here, what is this node? It is fast's next. If the fast next is null, then slow pointer has reached the middle node of the list. So this will be our first exit condition. Let's write the while loop. While fast's next is not null. This means until fast reaches the null pointer, we will traverse the list. Once fast reaches the null pointer, the loop will break. So what we need to do inside? We need to move slow by 1 and fast by 2. So slow equal to slow dash greater than next. And fast will be fast equal to fast dash greater than next. So fast is incremented by 2. And once we come out of this loop, we know for sure that slow is pointing to the middle node of the list. So we'll simply return slow. Now let's build logic to find the second middle node of the even size list, which is this node. To begin with, slow pointer is pointing to the head node and fast pointer also pointing to the head node. We increment slow by 1, so slow will point here, and we increment fast by 2, so fast will point here. Again we increment slow by 1, slow will point here, and we increment fast by 2, so fast will point here. Again we will increment slow by 1, so slow will point here, and fast by 2. So where the fast will point now? So fast will point to the null, because fast next is this node and this node's next is null. In this case, if you notice carefully, once the fast node reaches null, slow is pointing to the second middle of the list. So for this case, what will be our exit condition? Fast is not equal to null and. Now this code should cover both even and odd list scenarios. Now let's build logic to find first middle of the even size list. To begin with, if the list is empty, head pointer will be null. So in that case, we'll simply return null. Again, we use two pointers, slow pointer and fast pointer, and both are pointing to head to begin with. So slow is pointing to head, slow pointer, and fast is also pointing to head. So we have a fast pointer. For the odd size list, we basically check for this condition. Fast next is not equal to null, which means until fast reaches the last node, if fast reaches here, slow will point to the middle node. Now let's figure out the exit condition for even size list. Within the loop, we increment slow by 1, so slow will point here, and we increment fast by 2, so fast will point here. Again we increment slow by 1 node, so slow will point here, and fast by 2 nodes, so fast will point here. Notice here, now slow is pointing to the first middle of the list, right? Then what should be our exit condition? Look at this. At this point, fast next is this node, right? Fast next, and this node's next is null. Once fast next reaches null, fast pointer will point to the second last node and slow pointer will point to the first middle node. So let's write this condition: fast next. So if this happens, slow pointer will point to the first middle node and we simply return slow. Now let's see the complete working code. Here is the complete working code. This structure represents linked list node. And here is the function to find the second middle of the linked list. And here is the function to find the first middle of the linked list. Pause the video and analyze this code yourself. And how this code will behave if the linked list has only one node or only two nodes. Share your answers in the comment section below. Most interview solutions return the second middle node, but now you know how to return either one. This slow and fast pointer movement technique appears in many linked list problems. So understanding this pattern is extremely important. If you found this video useful, please like and subscribe.